All right, 4.6 perform operations with complex numbers. You guys probably studied this a little bit before, but remember you can't take the square root of the negative. Whenever you take the square root of the negative, you got to represent it with the letter I or imaginary. Now, imaginary can go back to a real number by squaring it because I squared equals -1. So we're going to do everything with complex numbers, add, subtract, multiply, divide, all of that stuff. So first step, solving. So we subtract 11 from both sides. We get 2x squared equals -48. Divide by 2, divide by 2. X squared equals -24. Then we take the square root and take the square root. Now, when we take the square root, we got x equals, you always have to put plus or minus when you take the square root of something, okay, because it's a positive, negative answer. Now, let's look at 24 first. Okay, 24 has a perfect square factor of 4. So we can break that down into 4 and 6, and square root of 4 is 2, so it'll be square root of 6. But when we have that negative right there, remember the square root of -1 is I, okay? And 24 times negative, square root of 24 times square root of -1 is negative, square root of -24. So where you want to put that I is you want to write this as 2 times I times square root of 6. And that would be your answer. Okay? So, whenever you have a square root with a negative on it, you need to have an I. The I should usually go before the square root sign. Usually before the square root sign is where you want to write it. So make sure you include that. You can practice on those. All of those should, for the most part, come out with the I on them. So make sure you write the I with it. Okay, complex numbers. We're talking about real numbers or numbers that don't have an I with it, or the zero, it's 0 times I. Imaginary numbers can have a real part and an imaginary part, but pure imaginary numbers only have the imaginary part. So that's when we talk about complex numbers. Complex numbers, sum and difference, it's the exact same thing. You're just going to add like terms. So, give us room already. All right, so the first one, you got 8 plus 5. You just want to combine like terms with this plus. 8 plus 5 is 13. Negative I plus 4I is 3I. And that is it. Just like if it was X. Now, subtraction, what I like to do is distribute the negatives so I don't make any mistakes. So I'd rewrite it as 7 minus 6I minus 3 plus 6I. And when I combine like terms, 7 minus 3 is 4, and negative 6I plus 6I cancels out. So my answer is just 4. So that's just real. The last one, again, I would distribute that negative. So it would be 10 minus 6 minus 7I plus 4I. So we'd have 10 minus 6 is 4, negative 7I plus 4 is negative 3I, and that would be your answer. In standard form for complex numbers, the real part always goes first, the imaginary part always goes second. You practice adding, subtracting imaginary numbers. Let's go to multiplying, okay? The main error is make sure we multiply I squared turns into -1, okay? So let's distribute. We got 4I times -6 is negative 24I. We got 4I times I, which is 4I squared. So again, I squared needs to turn -1, so it becomes negative 24I plus 4 times -1. Now, once you get doing this enough, you'll realize, well, every time it has an I squared, it's just going to change the sign because it's multiplied by -1. So if you want to do that right now, if you see that's 4I squared, you know that's going to be -4. You can do that right off the bat. And the reason I rewrote it as -4 minus 24I is because they said write it in standard form. And in standard form, the real part goes first, the imaginary part goes second. Okay? So make sure you always account for that. This one's just FOILing. We got -36. You have 63I. We got -2I times -4, which is positive 8I. And we have -2I times 7, which is -14I squared. So we got 63I plus 8I is 71I minus 36. And -14 times I squared. Remember, I squared is -1. So what's negative 1 times negative 14 is positive 14. So then we just combine like terms. So it would be negative 36 plus 14 is what? Negative 26, negative 22 plus 71i. Again, when we want to put it in standard form, the real part goes first, the imaginary part goes second. Okay, just to show that negative 14i squared, negative 14 times negative 1, which gives you to positive 14. Okay. So that's how you multiply complex numbers. Dividing complex numbers, you have to multiply by the complex conjugate, just like we did when 4.5, when you had to get rid of a radical on the bottom, you have to do that for imaginary. So the complex conjugate of the bottom, if you have 7 plus 5i, 1 minus 4i, the complex conjugate of that would be 1 plus 4i. And it's the same rule as earlier. We picked 1 plus 4i because when we multiply 1 minus 4i and 1 plus 4i, that middle term, which will be the imaginary term, will cancel out. Therefore, you'll have no imaginary parts in the bottom. And just like radicals, you can't have any radicals in the denominator, you can't have any imaginary parts in the denominator. So now what we're going to do is FOIL. FOIL the top. So we got 7. We have 28i. And it's okay if we have imaginary parts on top, we just can't have it on the bottom. We have 5i, and we have, what is that, 20i squared, which, remember, I squared is negative 1, so that makes negative 20. If we want to simplify right off the top, okay, I'm just kind of taking a shortcut right there, so I'm less writing later. Then on this one, we have 1 times 1 is 1, we have 4i, and we have negative 4i. Well, every time you pick the complex conjugate, the two middle terms should cancel out, so you don't even have to worry about multiplying. That's why we do that. And then we have negative 4i, and we have negative 4i times 4i, which would be negative 16i squared. Which again, remember, I squared is negative 1, so that'd make it positive 16. So we got 1 plus 16. So if we simplify this, we have 7 and negative 20, which is negative 13. 28i plus 5i is 33i over 1 plus 16, which is 17. You can leave it like this, or you can split it apart where you divide each part by 17 and write it as negative 13 over 17 plus 33i over 17. Either way works. Doesn't matter what you want to do. So it's pretty much the same rules as x. Just every time you get I squared, turn into a negative 1. And that's all you have to do on that. Notice how there's only real parts on the bottom. There's no imaginary parts on the bottom, which is what you want when we simplify and divide complex numbers. Applying complex numbers is pretty easy. The real axis, let me double check this real quick. Okay, the real axis is horizontal, and the imaginary, let's write out the whole word, is the up and down axis. So if they say plot complex numbers, they say 3 minus 2i, you're going to go right 3 and down 2 for the imaginary. That'd be A. And then B, you go left 2 and then up 4. 1, 2, 3, 4 for B. And then C is 3i. And then negative 4, you go left 4 and down 3. So that's how you go about graphing. Just do the real part first, go left to right on the real part, go up and down the imaginary part. Okay? Pretty easy. Not much to that. And absolute value, this is the one that kind of trips people up. But if you think about it, what they're showing right here is the Pythagorean theorem. Sorry, I moved that. They're showing the Pythagorean theorem. But basically, all we got to do is use this formula. And if you can't memorize that formula, that's okay. That's one of those where I can write on the board if you need it for a final, and I don't think you'll need it for the EOC. So, or a test. So what you want to do is the square root of A. Remember, the form is A plus BI. So when they say square root of A squared plus B squared, they just want the term in front of the B. Okay, they don't want I with it. So when I say -4 plus 3i, what you do is a is -4, so -4 squared, plus b is 3. It's not 3i, it's just b. So 3 squared. Then you have 16 plus 9 is 25, which is 5. So the absolute value of that would be 5. So basically, the distance from the origin and that point is 5 units, is what they're finding when they do that. -3i. Okay, on this one, and the last one, sorry, a was -4 and b was 3. On this one, there is no a, so it's 0, and b is -3. So we write it as a squared, so 0 squared plus -3 squared, which gives us 0 plus 9, which gives us 9, which gives us 3. So the answer would be 3 on that one. And that's all you really have to do on those absolute values. Is if you can, I don't care if you memorize this formula, I prefer you did, but I don't care if you do. That's not a big deal if you don't. But you got to be able to apply it. You got to be able to take your A and B and plug it in there. And once you can do that, you'll be fine. Again, practice plotting and find the absolute value of each of those. That's your homework. If you have questions, ask in class, and that is it.